so this one is in production already. Okay, we have the Visual Studio Code. We have different models that we can use in agent mode or just modify mode. Which one you prefer? Yeah, agent mode seems to be powerful, but then stuffing up stuff. Pendulum. Should we have another version of it? Shall we? Oh, because it has a separate JavaScript, this one. It has a separate JavaScript. Yeah, let's create the copy, pop it in. We'll run it locally, obviously. Start locally, Copilot, restart Visual Studio. Okay, Copilot, add file to chat, new chat. Okay, so the big choice. Are we asking agent or edit? Asking agent or edit. And I have to remember to run it locally as well. And which model are we choosing? Which model? Premium? Standard? Start with 4.0. Okay, so we want to add audio functionality. Now, for each pendulum, we should have audio on, off. That will enable the sound. We want it to be off by default. And we wanted to do a frequency on the x-axis, so on the horizontal plane, and we wanted to do amplitude of the tone on the vertical plane, so on the y-axis. So doing agent or edit. Okay, we added all the folder which only has HTML and JavaScript code. Web audio API sounds good. It's doing a sine oscillator. Seem to know what's what. Shouldn't be too complicated. Okay, real quick, what do you see on the screen?
I see a web page titled Multi-Pendulum Drawing Game. On the left, there's a dynamic drawing created by a multi-pendulum system, and on the right are controls for adjusting the length, angle, and damping of 3 pendulums, along with options for color and drawing trails. There are also buttons for pause, reset.
Okay, how would you move audio functionality to this simulation/game?
You could integrate audio functionality by mapping the movement of the pendulums to sound parameters. For example, the position or speed of a pendulum could control the pitch or volume of a tone. You could also use sound effects for interactions, like adjusting the controls or when the drawing trails intersect, adding an interactive auditory experience to the visual patterns.
By pitch, do you mean frequency? Or so how would you map both the X and Y axis on the canvas?
Yes, pitch typically refers to frequency. You can map the x-axis position of a pendulum to control the frequency of a sound, so moving horizontally would change the pitch. Similarly, you could map the y-axis position to control the pitch as well, or perhaps the y-axis could control the volume or another audio characteristic, allowing for complex sound variations as the pendulums move.
And we don't have the audio. What did we do? The audio functionality has been added to the pendulum search in each pendulum now. Yeah, the sound generated based on the pendulum's position. Okay, that doesn't work. Script.js. Did we? Okay. Okay, so that makes sense. Let's make this one red for a sec. Make that one blue, just for the sake of simplicity. Okay, how annoying is that? Let's damp. Okay, reset trails. So it meant to be volume. It meant to be volume on the y-axis and frequency on the x-axis. Not sure if it's correct or not. Okay, so mapping the x-axis frequency. So moving horizontally would change the pitch. Yeah, y-axis should control the volume. How do we make the sound better? Okay, that's pretty annoying. How do we improve it? Okay, so we have the audio working. A y-axis mapped to frequency and the y-axis mapped to volume and the x-axis mapped to frequency. How would you actually improve it?
Okay. To make the audio more pleasant, you could try using different sound types instead of just simple tones. You could also map the pendulum speed or velocity to various audio parameters, like the filter cutoff, reverb, or delay, to create richer sounds. Additionally, incorporating musical scales or harmonies based on their positions can make the audio more musical and enjoyable.
Can we actually do like 3 piano notes or something? Is that possible?
Yes, absolutely.
No, I know it's
You could
possible.
assign three distinct piano.
Wait a sec. Okay, wait. For each pendulum, can we have a different instrument for each pendulum? And instead of the volume control, we want to do like a timbre or something. What do you think of that?
That's an excellent idea. Assigning a different instrument to each pendulum would create a richer, more musical experience. Instead of controlling volume, mapping the movement to timbre changes, like adjusting filters or other effects, could produce dynamic sound variations that reflect the complexity of the pendulum's motion. This would make the interaction more expressive and engaging.
Okay, so I have like two problems. First of all, sometimes the audio would not work even though we interacted with the screen. So we just need to turn it into a question for the developer to check the code. We have a professional developer doing the coding. And the other thing is, we want to turn the discussion into, again, a prompt for the developer. So we want different instrument for different pendulum. We want the frequency on the horizontal plane of the canvas and the timbre or something else on the y-axis.
Okay, I can definitely phrase those points for the developer. So first, you'd like them to investigate why the audio sometimes doesn't work, even with screen interaction. Second, you want to suggest implementing different instruments for each pendulum, mapping the horizontal movement to frequency and the vertical movement to timbre or other sound effects. I can put that together for them. Would you like me to phrase it as a clear message for the developer?
Yeah, I think it's good already, as is. Okay, so first, investigate why the audio sometimes doesn't work, even with the screen interaction. Second, we want implementing different instruments for each pendulum, mapping the horizontal movement to frequency and the vertical movement to timbre, or other sound effects. So that's 4.0. Okay, there's some sort of audio locking is happening. So I'm modifying the JavaScript. Yeah, why is it so annoying?
the frequency range to a more pleasant range, such as 200 Hz to 800 Hz, instead of 0 Hz to 1000 Hz. Smooth frequency changes. Use a low-pass filter or interpolate frequency changes to avoid abrupt shifts. Adjust timbre. Use a more subtle filter effect or reduce the range of the filter frequency. Lower volume. Reduce the maximum gain to make the sound less intrusive. I'll implement these changes now. Made changes. The audio settings have been adjusted to make the sounds less annoying. Frequency range, limited to 200 Hz to 800 Hz for a more pleasant tone. Volume, reduced the maximum gain to 0.3. Timbre control, filter frequency is now mapped to a subtle range of 500 Hz to 2000 Hz. Let me know if further tweaks are needed.